Hey, what's up, guys? So today I want to demonstrate how you can print out a linked list in reverse without changing the pointers. And it'll be a singly linked list that you can print in reverse three different ways. So the three different ways are one of them is gonna consist of using a stack. Another is gonna consist of using a recursion, and the other one will be interesting. It'll just kind of be a repeat and recycle, but it's really not very efficient, but it's still a way. So let's go ahead and get started. We're gonna go ahead and get started by creating a linked list because I just can't seem to find one. So let's go ahead and create it really quick. So here I sped up the recording a little bit, and it's just to show that we are creating a linked list. Here I'm creating a method that I'm going to use for testing the actual linked list, because you should actually test whatever you're doing. And it took more time than this video deserves to create the linked list, so I just went ahead and sped this up. Right now I'm just writing a test to check that the list actually, I'm not even at the list yet. Here, I'm just checking to see that the actual test method works like it's supposed to. And then we're going to get into writing tests for the list. First thing, before we create the list, we want to add a couple of tests, and just to check for size and check for adding one element to the list. As you can see, when I run these tests, it shows that that they passed or they failed, and it's really just a very simple way to test your code, just by comparing values. So here I am adding the demo link list, and I just start adding everything into it. It's going to have the T for the data, and then a no T for next. And we're going to go ahead and start adding the add method, which means we're going to be adding a value into the list. And if we first check to see if the head is null. If it's not, we add it at the head. If the head is not null, then we add it after the head. And we're going to be tracking the tail, so we just add it at the tail, and we point the tail over to the tail next. And once we do that, we can one of the things is we have to make sure that we initialize the values, the head and the tail, properly, and we need to make sure that we initialize the size as well. You notice that size is actually underscore size, not size the method, and we have a whole bunch of errors here as usual. And one of the errors that I ran into here was that I'm declaring the node and the demo link list in the same file. And for some reason, it didn't like me using T for node and T for the linked list, so I changed the node to N, and left the template T. I think there's a conflict, because when it sees that value, it affects everything else. So I had to go ahead and change it, and then I start passing the test, passing a test and modifying it. Once I get to a point where I actually have the list, then we're going to get into actually creating the reverse values. So we get into, once we have everything in place, then we can start creating the methods to reverse the list. And like I said, there's three ways that we're going to reverse the list, and those three ways will be different. So we need to just make sure that our actual list actually works like it's supposed to. I'm gonna probably speed this up as well, because there's just no point in suffering through all this creation of a linked list. Okay, so now that we got this, Now let's get into print, the different ways that we can do print reverse method 1. So we'll say, first we'll go the simplest way, which is print recursive. Print recursive, print method 1, right? And we have to pass it the node T and we'll say that template class T head, or we'll say current. And we'll say if current equals null pointer, we return. Okay, else print method 1 current next, right? And then we'll say std cout current data. We'll say that in this case, we'll do this. We'll say, we have to say else, we say print method and data. And this is our first approach. And we have to say std endo. And we are going to print the list print method 1 demo list head node, and let's run it. Current data. Okay, there we go. So we did print it in reverse, 5, 4, 3, 2, and I'm not sure why it didn't do the null portion. 5, 4, 3. Oh, it did null all by itself. That's interesting. That's interesting. It did null. Oh, because it prints it first. Yeah, this is not right. Yeah, this is not right. Right, because when it gets to null, it doesn't print. It shouldn't print. That's wrong. So there we go. Okay, so then the other method is using a stack. And in order to use a stack, we need to create our linked list to behave like a stack, right? So what we can do is we can say node t push, actually void push node t, not node t. We'll say value, and we'll say similar to what we did here. We'll say if head equals no pointer, head equals no data, right? The problem and tail equals head, right? So we push, actually, when we push, we're going to say the tail equals head. But if there is something there, we're going to still push to the end here, and we're pushing to the tail. Okay, that's fine. But we are going to, in that case, just call add value. But when we remove, we're going to say pop t pop, and we're going to say if, and this is where we have to pop from the end, and we have to. That gets a little tricky because we have to keep track of the previous. We don't want to do that. No, let's not do this. Forget. Let's ditch all this. Let's ditch that effort. Instead, what we can do is we can bring in stack. And what we can do, we can call print method 2. We pass the current, except that what we're going to do is we're going to say no t, and we're going to call this the head instead. No t current equals head, while head not equal to null pointer. Actually, not head. While current equals current next. And what we do is we create a stack t stack current stack. And we're going to say current stack dot push back current data. We're going to say while current stack dot empty, not current stack empty. We're going to say cout val. And what we have to do, we have to extract the value, and we're going to say t val equals current stack dot I want to say peak or something. Let me see. Let's take a quick look. Let's see how they use it. So push is push and pop. while not stack is empty, we got to get the top and then pop. Okay. So it's current stack. Now into print method 2. So we'll call print method 2 demo this get hit node. Okay. And it's really push. And this is an iterative version. If they say do an iterative version of printing in reverse without using the recursive alternative. So this is using an iterative version using a stack. It's similar in a way, except the stack is more flexible. Using a stack is more flexible than using recursion. Because the stack will run out of space, whereas the current stack is running off the heap, so it's probably better. In this case, we're just storing T in it, so it should be fine. So let's run it. Okay, something 5, 4, 3, 2, 1. So here we need to do this std endo std endo t like this, and we probably want to do something like this. So this is going to do method 2. So let's go ahead and run it. It's taking its time, but we can see method 1 543, method 2 543. We know that we stored. We probably want to print it in normal. So let's go ahead and print it normal. Print normal, and we could say log current not equal no pointer. Oops, that's what's supposed to be not equal no pointer. We could say current equals current. Next, and we can say to the out current. There you go. Okay, so we'll call this print normal, and like that. I don't even know if we need the template class in OT, but we'll print it normal first. So we'll call this here print normal. Okay, 3, 4, 5 is normal. Reverse is 5, 4, 3. Method 2. So now, what if you wanted to print it another way, where you actually take and you print it, but you don't? A recursive is not an option, and using a stack is not an option. So we'll have a print method 3. So let's say that we have a print method 3. So this one works a little bit different in that we have to take and we have to, one is get a count. In other words, the size. Since we know the size equals size, right? We have to get the size. So being that we have the size, we can get the size. Let's say that we don't have the size. So let's say the size is 0. And then after getting the size, we go from equal I equal size minus 1, right? I greater than equal to 0, and go I minus minus, and then we print at that. So in order for one to get decided, we just say we could say node t current equals head for while current not equal no pointer current current equals current next, right? And we every time we navigate next, we increment the size plus plus. So now we got the size. So now we do something similar here. Oh, this thing is slow today. Okay, so we'll say that current equals head. Well, current not equal pointer. Before we move, we do increment the size, but if size equal I, right? If size equal I, we go ahead and print it out. Current data. And then we break out of it, right? We don't have to break. I mean, we don't have to keep going. We just break out of it because we don't have to keep going. And then we just keep going throughout. And then at the end of it all, we just say std cout std and go. And this it's not very effective or efficient because it's doing the loop first to get the size, which is no big deal. It's okay, one time, one pass through. We could have got the size from the list itself, but since we only have the head node, we just have that. We get the size. Since we have the size, then we have to loop through every time for each one of these to find it, and we have to search until we find it. So this is like basically n times n, I think is what you think about, because it's like n times n divided by 2 or something, the algorithm. But it will do what it's supposed to do. Okay, but now keep in mind this broke here, and it goes to the next one. So that should be fine. So let's go ahead and call it print method 3 and see if that works. Print method 3 didn't seem to do anything. I think we have an error here. Let's try it again. Okay, now I'll give you an error. Okay, there we go. Okay, so here we didn't say method 3. We could actually say std cout method 3 std and you could say std and let's try it again. Huh. Oh. What? Method 1, method 2, method 3. Current equals head, while current not equal no pointer. Current equals current x, size plus plus. For I equals I, size minus 1. I'll put out some things. Let's see what it's coming up with. So it does have a size 3. Current equals head, while current not equal no pointer. And size equals oh yeah, here's the problem. We need to say we need to say we're changing the size. We don't want to do that. We need to say int uh, new index or something. If new index equals I, then we do it new index. Okay, so that's what's wrong with it. Okay. And so method three. So method three also works. So there it is. Three different ways of getting a list to print. So let's take a look at them. So normal, of course, we just loop through the list. We go through next, and then we print it out. Method one is using recursion. So if you know recursion, you know that it's going to go very deep all the way down. It doesn't begin printing until it reaches the end. When it reaches the end, it returns. And then since it went deep from here, it went all the way down, kept going down until it reached this point. Then when it jumps out, finally it jumps out and it starts printing every node from the end. So it's going to print the data and then go back to the next node, print the next data, and so on. The print method number two is using an actual stack, which is very similar because what we're doing is storing everything into the stack. And then we want the stack in order. We just pop everything off the stack. We take everything stored in the stack. After storing it, after storing everything in the stack, we take and pop everything off the stack. Since popping is last in, first out, since the last one in is the first one out, it's just gonna automatically do it in reverse order. And of course, print method number three, very inefficient, but it would be more like, this would be similar, like if you wanted to index your list and you wanted to get to a size and every time you have to go through, walk the entire list, find it, and then get that node out of there. You could do it that way. So the first thing we had to do in that case is get the size and then walk through it. But of course, this is almost like n times n, so very inefficient, not the best recommended way. You got to keep in mind that the stack is in ways it's not going to be quite like that because you walk the list one time, you push it onto the stick one time. So this is like n times two because one time for the stack and another time another time to walk the list to pop everything off the stack. So you walk the list one time, push it onto the stack. But now remember, this actually doubles the space in your program. So this is going to double the amount of space, and this one doesn't double the amount of space, but it's just a lot more processing. Print method number three is just a lot more processing. And this one, recursion, was always dangerous, and you always got to find something, the alternative to recursion, because the recursion is actually executed on the stack itself of the program, and well, you can quickly run out of space doing things like that. So there are your three methods. Hope you enjoy. If you like this video, give it a thumbs up. If you don't, give it 2 thumbs down. Leave your comments, questions. They're all welcome. And thanks for watching.